Right, today we're going to look at momentum and forces, specifically momentum changes, okay? Now, remember from a previous video that momentum is equal to the mass times the velocity, yeah? P, which is momentum, is equal to m times v. Now, another key idea from here is that a large change in momentum happening over a very short period of time is going to cause a huge force to be exerted. Now, a large change in momentum over a very short period of time can, in some situations, be pretty deadly, okay? We're going to look at a situation like that in a minute, but first, let's see why. Okay, so firstly, from a previous video, you know that force is equal to mass times by acceleration. Yeah, that's Newton's second law. So force is mass times acceleration. You also know from a previous video what acceleration is. Acceleration is just the change in velocity. Remember that delta symbol means change in, that little triangle. Change in velocity divided by the time taken. Okay, right, so let's plug this equation A into this equation here. Okay, what do we get? So you get force is equal to the mass times by the change in velocity divided by the time. There we go, we've got an equation. Now, you need to remember this equation. So what does this bit at the top look like, firstly? M times delta V. What does M times delta V look like? So this here and this here look very similar, don't they? mv is momentum. M delta V is change in momentum. And then T on the bottom is time. And then we've got force here as well. Okay, so force is equal to change in momentum over time. So can you see now why a large change in momentum over a short period of time is going to give you a very large force? Yeah, if you take a number and you divide it by a small number, in other words, you make time very short, make time very small, then you're going to get a very, very big force out here. Now let's have a look at this in a question. Now, what I've got here is a crash test. A crash test involving a car. A car is moving at 20 meters per second. The car has a mass of 1,500 kilograms. And it's going to collide with a wall and come to a stop in 0.5 seconds. Calculate the force on the car. So how would we approach this equation? How would we approach this question? So first things first, let's plug it into this equation here. Okay, so F is mass times change in velocity. So the mass is 1500. The change in velocity, if it goes from 20 to 0, technically is going to be minus 20. I'm just going to put in 20 here. And then we're going to divide that by the time taken, 0.5. Okay, so 1500 times by 20 is going to give you 30,000. Divide that by 0.5 is going to give you 60,000 newtons of force. So this crash test, the crash test dummy in that car, is going to experience 60,000 newtons of force. That's quite a lot of force. Yeah, that's a very large amount of force. So it's going to experience 60,000 newtons of force. Now there's several things that we can do in cars to reduce that force. Okay, and all of them involve extending the collision over a longer period of time. Let me show you some examples. So in cars, we've got airbags. Okay, now an airbag, when your head hits an airbag, it's going to compress the airbag, and that's going to take some time. Yeah, because that takes time, you're extending that momentum change over a larger period of time, so you're going to reduce the force. You've got seatbelts. Now seatbelts in cars stretch very slightly when you are in a collision. Because they're going to stretch very slightly, that's going to take time to happen, which will increase the time of the momentum change, which will reduce the force on the passenger. You've got crumple zones in a car. The front end of the car is designed to crumple under a large crash, which will mean that's going to take time to happen, which will reduce the force on the driver. Yeah, more time, longer change. The change in momentum is going to take longer, so the force will go down. Other examples. So you've got bike helmets. Bike helmets have got polystyrene in them. That polystyrene is going to compress slightly. That's going to take time. That will cushion the impact. Yeah, it will take longer for that momentum change to happen, which will make the force lower. Same thing for rubber tiles on the floor in a playground. You might, if you do like gymnastics or anything like that, you've got crash mats on the floor. So if you hit those crash mats, that takes time to compress. All of these things are going to extend the time taken for the momentum change to happen, which will reduce the impact of the force. Okay. Okay, I think that will do for now. I will see you in the next video.